Hey everyone, and welcome to the Cognitive Systems Institute Speaker Series. I'm happy to introduce our presenters today, Roberto Sicconi and Maggie Stys. They are founders of a company called TeleLingo. Before founding TeleLingo, Maggie and Roberto worked for IBM Research. Roberto managed the embedded speech team that developed the first in-car navigation and infotainment system, Sally, for conversational access in cars in collaboration with Honda, Alpine, and BMW. He was the program director for IBM Watson Jeopardy team. He was responsible for starting the Watson for Healthcare Initiative for clinical decision support and Watson Customer Engagement Advisor digital assistant. His expertise spans across wireless communications, speech, image and video processing, dialogue management, natural language processing, machine learning, artificial intelligence applied to automotive, mobile computing, telecom, healthcare, financial services, customer support, and education, and virtual assistants. Maggie, also known as Malgorzata, pioneered virtual assistants as conversational machines for IBM Watson. She built up the IBM CIO Global Innovation Teams. She led multi-million-dollar advanced technology deals across industry and technology clients, including a wellness consortium. Her unique experience includes a career in the convergence of new business and cutting-edge technology. Her expertise is in natural language processing, linguistics, virtual assistants, dialogue and discourse management, innovation management, and business strategy and operations. They both have a strong passion for innovation. Help me welcome Roberto and Maggie, who will present artificial intelligence in the car. Thanks for being our presenters. I'll turn the call over to you both.
Okay, thank you very much, Diane, for this kind introduction and for the opportunity to speak at the IBM CSIG Talk Series. So as Diane mentioned, both Roberto and I are ex-IBMers, so speaking at IBM, again, feels a little bit like two alumni coming back to visit their graduate school. We do appreciate the invitation. We're very happy to be here. So we founded TeleLingo back in 2014, and since then we have been working on two projects, one in automotive and one in education, two seemingly unrelated areas. What we would like to present today is the AI Automotive Project. Our company's mission is to save lives, and to that end, we have designed a LingoFit, an intelligent hardware and software to detect inattentive driving and remind the driver to pay attention. So if we move to the next slide, let's start by watching a short video describing our company's mission, problems it addresses, and the solutions we propose. By the way, what you see on the screen right now are the team members.
Have you ever been distracted while you were driving? Has exhaustion ever taken you over to the point of falling asleep at the wheel? Have you ever found yourself glancing at a text, changing the radio station, eating a snack, drinking coffee, looking at directions? You look up and get a scare? These are the few of the contributors to the escalating fatalities on our roads today. 80,000 in the U.S. last year alone. This has got to stop. LingoFit is the answer. Smart cameras monitor where the attention of the driver is directed and the scene ahead. Artificial intelligence analyzes vehicle dynamics, computes driving risk level, and compares it with the driver's attention level. When risks are detected, acoustic or verbal warnings give the driver the opportunity to correct the behavior in time. The driver on top relies on LingoFit. The one at the bottom took a chance. Look ahead. Our goal with LingoFit is to save lives by keeping drivers safe. Just the help you need, when you need it, in real time.
So when it comes to mobility, cars are becoming supercomputers on wheels. And, most of us, I think, have experienced or heard about driving assist technologies that are becoming more and more pervasive, and they make cars smarter. So naturally, we think that our roads would become safer. In fact, the opposite is true. Drivers tend to delegate too much control to the car, way beyond what they should be doing right now. And as a result, we have an escalating problem of distracted and drowsy driving. It's a distracted driving epidemic in the U.S. That we're facing, and policing alone does not seem to work. According to NHTSA, over the last 2 years, the number of accidents has been rising, and this is after years of slow but steady decline. The main cause of this reversal, yes, you guessed it, the sharp increase in distracted driving. both distracted and drowsy driving account for 80,000 accidents and 8,000 deaths per year, and that is up 15% since 2014. The other number that you see there on the slide is 40 billion, and that is the yearly cost of claims related to distracted driving. Despite state-issued bans, the use of cell phones while driving is still on the rise. So, if cell phone use is so irresistible and so inevitable, the question that we posed to ourselves was, how can we manage proper access to smartphone services while eliminating distractions? So in this presentation, we would like to explain how smart, context-aware digital assistant with co-pilot expertise can come to the rescue of this problem. How we can estimate the instant level of risk, of driving risk, how we can evaluate drivers' attention and the ability to respond to the required tasks and emergencies. How can we interact with the driver? How do we know when to speak, when to listen to them? How do we know how can we be most helpful and do it in a non-intrusive way as much as possible? And finally, how do we inform and coach our drivers to help them minimize risks and improve their performance? Okay, so the next slide has a little bit more statistics, but let's look at our drivers first. So as we know, drivers are surrounded by all kinds of gadgets, and it's not just smartphones. They're distracted, but there are also those drivers who are simply tired and drowsy. So how do we combat them? Then another category of drivers is those taking long, boring trips with nothing going on for miles on end. So how do we help these guys? Those are some of the questions that we have been tackling. Let's look at some statistics in the middle column. So in the U.S., there are 660,000 smartphones used at any given time. So when we first looked at this statistic, it was pretty staggering that at any point in time we have so many people using smartphones in their cars. 1/3 of those drivers admit to texting while driving. 29% admit they surf the internet while they're driving. Half of the drivers say they make phone calls. And this is the most stunning one. 1/10 of the drivers shoot videos while behind the wheel. In 2016, we have witnessed 3,500 deaths on U.S. roads because of distracted driving. And by the way, 39% of those drivers were in their 20s. So one thing to note here also is that the government data that we're citing on distracted driving may not show the full extent of the problem, and that's because of the difficulty of gathering this data. Drivers don't always admit they're multitasking. Okay, and then let's look at insurance companies and their problems. Those are problems of churn, cost, and fraud. In approving new rates, they calculate recent frequency of accidents and increase their rates, which I'm sure most of us have experienced. They have insufficient data about drivers, and the car insurance rates are skyrocketing. The quotes are up 14%, average of $900 per year since 2012. And this is statistics according to Trade Group Insurance Information Institute. Well, in the meantime, drivers keep looking down on their phones, and that has become the new normal in America. That trend is pushing up the number of accidents. So, Roberto, tell us a little bit about our secret sauce, about the TeleLingo solution.
Yes, as some of you may be aware, from an insurance point of view, one of the techniques to gather more information about driving style and potential risks associated to it is by using telematics services, mostly in forms of little boxes installed in your car. And then the policies are changing to something that is called the usage-based insurance, where depending on how fast you drive, how quickly you accelerate, decelerate, how fast you make the turns, you get into a certain classification in terms of risks associated to your driving habits. As it turns out, this is good but not sufficient information that insurance companies can use. The other part that is missing is what the driver is really doing. If you are an expert driver, driving high speed is probably less risky than for a beginner who may not even exceed the limits but may expose himself to higher risks. So what we want to do is analyze the driver, create a model, and keep it current and understand whether you are within the boundaries of the model that we created for you. The other aspect is understanding the actual risk that you're in. It's very different being at close to posted speed limits on a highway with no traffic than bumper-to-bumper traffic at lower speed in downtown Manhattan. We also want to make sure that any communications that we provide to the driver is handled so that we do not add to the existing distractions. So we are only using voice and sounds, no graphics and no touchscreen, and we use very carefully AI to understand the models, to understand the gaps, and I will get a little more into details here. The eventual goal is to create a unit that can be installed in the car, eventually in the rear view mirrors, that can help drivers do the best and get coached when they need. So the primary focus is on providing a solution that allows the drivers to keep their eyes on the road, hands on the wheel. What we do is use cameras, smart cameras that operate both in the visible and infrared domain, so they can work both at day and night. We analyze the driver attention, mostly head pose detection, and in the future also eye gaze tracking. And then we model the drive behavior. We extract information from the car, what we call car stress. We extract information about around the car, the traffic ahead of you, on the side, on the back of you, to understand what kind of risks you are undergoing, especially if you're not realizing or aware of them. And we model that risk. Then the two models are compared, and we use some AI to understand how much margin you have in handling this. If there's not enough because you are distracted, then you get notified by acoustic beeps in sophisticated sounds. In urgent cases, you also get a voice talking to you. If you're starting to get into a drowsiness situation, then we can apply stimulating exercises, mostly in forms of short question and answer sessions that are paced depending on the level of risk you're in. So if there's no risk around, then you can have longer sessions. Otherwise, we are very careful in playing with this. Additionally, if you are willing to wear biosensing wearables, we can collect additional information about your physical status, for instance, a heart rate variability and galvanic skin response, to get a sense of your stress and fatigue state, and then use that one to drive our comments too. Here's our main initial product. We are starting with a simple solution that consists in a mobile app running on mobile devices with an additional camera attached to it. We are in the process of integrating it and making it nicer than it is today. We are also looking at using mini PCs to provide more processing power and have a high ability to understand what the driver is doing. Going forward, we plan to use even higher and computing solutions and better cameras. We are starting to play with what is called the 3D cameras. It's a stereoscopic cameras that operate in both visible and infrared domain that give depth perception to have a better representation of the face, enhance the profile of the user, and better understanding of what the user is doing. Version 4 is the fully integrated unit that we plan on installing on windshields that includes all the features developed to that point, and then have the option of using a wearable bracelet. And then longer term, the idea is to license technology to car manufacturers so that you can embed it into the cars directly, for instance, inside the rearview mirror. Maggie?
Okay, so let's talk a little bit about the market. There are three markets we go after, and they're sorted on this slide by level of difficulty and opportunity that we see. The fleet management is our initial solution. It's by nature, it's a highly fragmented market, but not too cost sensitive, and even lower functionality is sufficient to gain traction. Fleet managers need to understand things like how the driver is doing, what's happening in the cabin. They obviously need to focus on the driver and the driver's performance, but the fleet management companies also care about their cargoes and the truck itself. Accidents often translate into significant business flow disruptions and loss of profits when deliveries are delayed. The ride sharing is the next market. It has a few companies with a larger number of drivers. They have similar needs to fleet management, but the device needs to be less bulky and less expensive. Ride sharing requires features like recording of unsafe events in the cabin, and distracted driving detection is also key. And then finally, we've already talked a little bit about insurance. This is definitely our biggest opportunity. It's a significantly bigger market, but it comes with tighter cost and integration constraints. And for insurance, the device needs to be really small and cheap, but the volumes are two orders of magnitude higher. Okay, so let's talk about unique of the Lingo Fit product. Roberto?
Yes, sort of to recap what you mentioned before, the important thing that we're bringing to the picture is the ability to monitor a driver, the driver's attention and the responsiveness. If you think about it, when you drive as a passenger, somebody else is driving the car. If you have driving experience, you naturally react to things you see through the windshield. If something is happening ahead of the car and the driver is not paying attention to it, you feel compelled to warn the driver to pay attention to it. Like sometimes is stopping right in front of the car and the driver is looking on the left or talking to you. So you of course don't want to pitch in all the time, but when you see that there is a need for it, you definitely do it. It's a self-survival skill, if you wish. So the more expert you are as a passenger, the more helpful you can be in deciding when to make comments and make suggestions to the driver. And this is exactly what we are trying to create here. A virtual co-pilot that is sitting next to you is quite most of the time is aware of what is happening around you and is looking at you, and then only when necessary is going to tell you, hey, look ahead, or stop doing it, or check the traffic, or that kind of messages. That requires intelligence. It cannot be just based on evaluating thresholds and how fast you're driving, whether you are braking slowly or not. It's much more complex picture that we need to understand, and that's why we're using AI for this. So in short, we are watching the driver, we monitor the attention level at all times, we watch the scene, we understand the risk level, and then we process this model to decide when to interact with the driver. We are not aware of any other solution that is doing it today. Talking about autonomous vehicles, one of the comments that some people make is, yes, but autonomous vehicles are around the corner. Sooner rather than later, we will be just all passengers in the cars, and the cars will make all the decisions. Well, maybe, but not that soon. If you look at the statistics from qualified consulting services, the projection is that there is going to be a growth of self-driving and autonomous vehicles, but it's going to take quite some time. Even in a best case scenario, assuming that no legal government oil prices are going to play against it, fully autonomous vehicles by 2032 are expected to lend into 32% of new cars with those features. Now, if you think about it, right now we have a little over 1 billion cars on the road. By then it will be 1.2 billion. So if you take 32% of more or less 90 million cars produced every year, you're talking about a 3% impact on cars on the road by 2032, and that's 15 years away. So the estimate is that it will take probably until 2050 to get to a 50% presence of autonomous vehicles, assuming that the cost of those cars are not going to discourage people from replacing the existing cars. And that leads to a few decades of traffic situation where you will have a mix of old-style cars with no driving assist, new cars with some level of self-driving capabilities, and even newer cars that will be fully autonomous. And guess who has to oversee all this? All the individual drivers. They will have to pay attention to what is happening. And so the old dream, you see a picture here of a fully self-driving car that can drive you to from A to B while you're having a good time with your friends, is coming to realization, but it will take much longer than anybody expects. And yes, we would like to be sitting and laying comfortably like the two guys here, but meantime, we have to pay attention as drivers. The cars will likely not to become all Google-like cars. They will have the ability to be driven by people, and they will expect drivers to be in control most of the time, if not all the time. And so the car has to know what you're doing. Are you watching the road? Are you ready to take control if needed? Are you asleep? And if so, the car has to make decisions on how to safely land the car in a safe position and wait until you're ready to take over. In addition, we are planning on using biosensors in the car to make sure that we can provide the best wellness conditions to you as a driver and passenger going forward. Now, I believe we have a few minutes left. We would welcome any questions you have, and we'll try to answer to the best of our knowledge. Thank you.
Yeah, I think we're ahead of our schedule a little bit, so we have more than 5 minutes for questions.
Thank you. Thank you, Maggie, and thank you, Roberto. I think this technology is very, very exciting, and as I've told you before, I wish I had it when my sons were learning how to drive, but they could still use this. I think anybody who's a new young driver, an aging driver, or anyone with a cell phone needs this technology. So let me open it up for questions. Audience, please press *1 on your phone to unmute your phone. If you're using audio on your computer, press the little microphone icon at the top of the screen. Are there questions?
Yeah, Diane, hi, this is Jeff. I have a question. This is a very interesting topic. My question is about like the pricing. Have you looked at the pricing model and the affordability of this product? And do you know, is it something that, you know, you've worked with insurance companies where, like, if I bought this and put it in my car, could it lead to a reduction in insurance rates?
Yes, no, you have an excellent point. As a matter of fact, that was our starting point last year when we contacted the major insurance companies in the U.S. and also in Europe. They have a very clearly defined target for hardware assist they're willing to bring into the car. Depending on the market, the budget is a little smaller in Europe than it is here, because telematics and usage-based insurance have been around for a longer period of time, so they kind of standardize the pricing levels. Just to give you an idea, typically OBD2 devices without cellular connectivity, so cost the insurance around $100. They can vary from $50 to $150. Some of them go even beyond it. Clearly, the lower the better from an insurance point of view. Once you start adding capabilities like camera and more processing power to handle it, of course the prices go up, and this is the biggest constraint that we are facing, and one of the reasons why we decided to explore other areas first, so that we can integrate the technology and reach the target that insurance companies are looking for. There are specific spaces. Diane was mentioning teenagers. In the case of teenager, even if you decide not to work with the insurance company and get a better rate for your teenager, thanks to an installed device, even between the parents and the teenagers, there's going to be a market for a little more expensive devices that can be installed that may not be, I would say, professional grade, like the ones we would need to develop for an insurance company, but they could cost a little more, and that would be a good way of guaranteeing peace of mind to the parents, and in a sense, some good guidance and coaching for the team. So that's a different market where we can afford the slightly higher prices, and that's one of the areas we're going after first. But for insurance companies, you're right, there is a definite target. Things may change a little bit. Right now, in the U.S., pricing of insurance companies is rising at about, depending on the insurance company, 7 to 15% year to year to compensate for mounting losses in claim costs, mostly caused by distracted driving. So as prices go up, the profits are probably going to go up too, and the thresholds for hardware that can be brought in to control what the drivers are doing is probably going to go up also. But for now, we are thinking about ranges that we were given last year.
Yeah, so just to add quickly to that, right, so there's the insurance definitely is going through some major changes, and they're rethinking, and it's not just the most innovative insurance technologies. I think all car insurance companies are looking at that, but there's also the point of view of the driver. So I'm sure most of us on this call are really excellent drivers, and we do not appreciate the 14% increase, year-to-year increase in our premiums. And so this, the device that we're offering would also, offers a chance for an average driver or a really good driver to pay less on their insurance, get discounts.
Yeah, there's another analogy I like to make. When I came to the States 20 years ago or so, one of the most expensive accessories you could buy for the car was a radar detector. And, at the time, I didn't feel like I needed one until I started getting tickets, and then I realized, okay, there's probably good reasons to buy one. And I did buy one, and then the second one, and the third one. And of course, it wasn't paid by the insurance, it was paid by me. And the reason why, I want to make sure that I would not get caught speeding occasionally. So for me, it was worth spending a couple of $100 to make sure that I would not get fined, and then have reflections also on my insurance at some point. I think that here we are approaching a phase where some drivers may see this as a way of monitoring their maybe not so good driving habits and get a gentle warning from a device before things get harsher, and then the police car stops them and then gives them a ticket. For distracted driving, you may have seen most of the states recently ran a week or month campaign making the tickets much harsher. Most of the states have increased the cost of the first violation, and even more so the second or the third one. So in some cases, you're talking about the $500 for the first infraction, and then potentially a driver's license suspension at the third one. So clearly, there is a big problem. The cost is going up, and I think that the cost of the device may be less of a problem once you face the alternatives.
Thank you. Are there other questions? We're almost out of time. Just another thought is that since drivers might need to be incented, like not getting a ticket or not getting in an accident to use this, I wonder if this could be a feature installed in new automobiles that you can't turn off, that are put in place to help you be safe.
Mm-hmm.
Because
yes.
I would be afraid if I gave this to my son, he'd turn it off.
Yeah, excellent point. As a matter of fact, some companies have started moving in that direction. Volvo is one. Chevy with Malibu already has a car, I think, on the market since a year or 2 years ago, where parents can configure the capabilities of the car, like the acceleration, speed limits, and other things that can be set by the parent and cannot be modified by the teenager. And the car can also report on position and speed and other things to the parent without telling anybody else, just to the parent. So there are, and it's embedded in the car. So clearly it's done for the parent to feel a little better about what the teenager is doing. And there's a good reason for it. The half of the cost of big accidents is caused by teenagers 16 to 21. I mean, 16 to 20. They are the highest users of mobile phones in the cars. 47% of them uses devices in their hands all the time, much more than any other age group. And for teenagers 16 to 19, car accidents are the leading cause of death. So it's not just an impression, it's a real problem that needs to be addressed.
Yep, and as a parent, I would buy that car that had that feature to keep my child safe. But thank you. We're out of time. Roberto, Maggie, I think this is amazing technology, and I thank you so much for presenting today. And audience, we will see you next time. Thanks, everyone.
Thank you. Thank you, Diane, for having us.
Bye-bye.